At first light, the mountain does not look like a mountain. It looks cut. A dark mass rising from the plain, ringed by vertical grooves, its crown flattened, its sides stripped into long fibrous columns, as if something vast once stood here and was removed. In old survey photographs, before roads and guardrails and interpretive signs, the scale is almost wrong. Horses stand at the base like insects. Men disappear against the wall. The surface is not random. It is striated, ordered, shockingly clean. And once you see it that way, the landscape begins to change. Mesas become severed tops. Buttes become splinters. Entire ranges begin to look less like geology and more like the remains of something the modern world has forgotten how to name. The accepted explanation is straightforward. Mountains rise through uplift, volcanism, intrusion, erosion. Flat tops are the residue of harder caprock resisting weather. Vertical columns form when lava cools and contracts. Rounded ridges are carved by water, ice, and time. This is the language of the modern earth sciences, built over 2 centuries of fieldwork, measurements, and models. It is coherent. It explains much. In most cases, it explains enough. A place like Devil's Tower becomes an igneous intrusion. A mesa becomes a remnant of a larger plateau. Petrified wood becomes buried forest transformed by minerals over millions of years. The story is stable. The terminology is stable. The categories are stable. But there is a moment, usually in photographs, when the official account begins to feel too complete. Not false. Just finished too early. Because the eye notices things the label does not answer. It notices sheer walls that look peeled rather than weathered. It notices summit surfaces that appear cut rather than broken. It notices fluted columns that resemble grain. It notices that certain isolated landforms bear the same profile, again and again, across distances too large for coincidence to feel comfortable. And the question arrives quietly. What if some of these formations were not merely shaped by erosion, but were the remnants of structures so large that geology inherited them and renamed them? That is the hidden theory. Not that every mountain is a stump. Not that all geology is fiction. The serious version is narrower and stranger. It proposes that some landforms now classified as volcanic necks, mesas, buttes, or erosional remnants may in fact be the basal remains of biological or quasi-biological megastructures from a world unlike the one described in modern timelines. In that reading, the mountain is not a peak at all. It is a severed base. The surrounding plains are not simply sedimentary basins. They are fields of debris, ash, and reworked matter. The old world did not vanish completely. It was absorbed into another explanation. Begin with form. Shape is not proof, but it is where all investigations begin. There is a reason people independently compare certain formations to stumps, trunks, roots and sword pillars long before they know the local geology. Some of the most famous examples display abrupt cylindrical geometry, radial cracking, flat or gently domed tops, and bark-like side texture. Basalt columns are said to form from cooling stress, yet in many formations the columns do not simply descend in neat polygons. They taper, fan, bend, cluster and fray. From a distance, the mass reads as wood more than rock. Up close, it becomes technical again. But distance matters. Patterns visible at scale often disappear under the microscope, not because they are false, but because classification breaks holes into parts until the original resemblance is no longer discussable. The stone remembers. Then look at proportion. Trees in the modern world are limited by fluid transport, gravity, wind load, cellular strength, atmosphere and fire. That is the standard objection, and it is a strong one. 40-mile tall trees sound absurd because present biology cannot support them. But the theory does not depend on present biology. It depends on the possibility that the Earth system itself was once different enough to permit forms we would now treat as impossible. Higher atmospheric density, different electrochemical conditions, different pressure gradients, different radiation balance, a biosphere operating on principles adjacent to, but not identical with, what survives now. That is speculative, yes, but speculation begins when the present model stops scaling cleanly backward. What matters is not whether modern redwoods reach the stratosphere. What matters is whether our current limits are being projected into a past that may not have shared them. The landscape around these formations raises the next problem. If a great butte is merely what remains after softer material eroded away, then where is the full infrastructure of its removal? Where are the volumes that match the disappearance? Geologists can answer that with long periods, basin deposition, transport and denudation. Again, that answer explains much. But at certain sites, the scale of absence becomes unnerving. Vast plains ring abrupt monoliths. Sediments spread outward in ways that feel less like patient weathering and more like catastrophic redistribution. Whole regions appear scraped, stripped, leveled, then dusted over. In the stump theory, those plains are not passive emptiness. They are the record of processing, pulverized matter, burn residue, slurry, reworked organics and minerals dispersed on a continental scale. Extreme? Certainly. Yet the old photographs of blasted hillsides, mined mesas, logged plateaus, and exposed strata often show the same visual language. Cut faces, layered spoil, transport corridors, and sudden truncation. The pattern does not disappear. There is also the issue of texture. Official geology describes columnar jointing, fracture planes, vesicles, weathering skins, mineral veins, all valid terms. But the visual resemblance between some mountain flanks and shredded fiber is not superficial. Long parallel grooves, stringy vertical segmentation, flared bases resembling root buttresses, splintered tops that appear torn rather than eroded. In some high-resolution aerial surveys, drainage channels branch across plateaus in patterns eerily close to vascular networks. No single image proves anything, yet dozens of images across different continents begin to suggest a recurring morphology. It is not only one tower in Wyoming or one mesa in the desert southwest. It is an entire family of forms. The scale changes, the pattern repeats. Supporters of the mainstream explanation deserve to be heard fairly here, because their strongest points are real. Rocks fracture in columns under known physical conditions. Lava and magma produce strikingly regular structures. Erosion isolates resistant cores. Differential weathering can flatten tops and steepen sides. Pseudomorphs and mineral replacement can create textures that mimic organic material. Human pattern recognition is notoriously overactive. We see faces in clouds and design in randomness. All of this is true, but the mainstream explanation tends to work by separating each anomaly from every other anomaly. One shape is volcanism, another is uplift, another is erosion, another is coincidence, another is pareidolia. What it rarely does is ask whether the same visual grammar appearing across separate classifications might indicate that the classifications themselves are masking a larger continuity. The weakness is not in the data, it is in the compartmentalization. The historical record introduces another layer. 19th century surveys often describe landscapes in language later edited out of scientific seriousness. Explorers wrote of gigantic stumps, petrified trunks the size of towers, root-like ridges, vitrified surfaces, and plains littered with strange debris. Sometimes they were being poetic, sometimes they were not. Early newspapers and local gazetteers are full of descriptions that read embarrassingly literal to modern eyes. Then, over time, the vocabulary narrows. What was once compared to timber becomes basalt. What was once called a giant trunk becomes a neck or plug. What was once noted as strange becomes normalized through naming. This is how paradigms harden. Not by proving every earlier observer foolish, but by teaching later observers which comparisons are no longer respectable. What changed was the explanation. Maps deepen the unease. On relief maps, satellite mosaics and shaded terrain models, one begins to notice radial systems around isolated masses, broad fan patterns, repeating circular perimeters and severed linear ridges that terminate with suspicious abruptness. The geography starts to look less like a random collection of mountains and more like fragments from a larger destroyed architecture. Some formations appear to have matching scale relationships, as if they belong to growth systems with internal proportion. Others sit inside basins that resemble extraction zones more than natural amphitheaters. Even where the geology is well described, the geometry remains unnervingly clean. Natural processes can indeed generate clean geometry, but when clean geometry appears alongside cut-like summits, fiber-like fluting, radial surrounds, and enormous debris fields, the burden of curiosity increases. There is a point at which dismissal becomes less scientific than investigation, and the scale widens further when the single case is abandoned. North America has its towers, buttes, table mountains, and giant petrified fields. South America has vast flat-top masses rising like amputated columns from jungle and cloud. Africa holds isolated inselbergs and stone trunks, whose weathering patterns seem almost manufactured. Australia presents stump-like mesas, standing above plains like broken pylons. Eurasia has basalt organs, pillar mountains, and severed plateaus whose forms echo the same profile. Different continents, different climates, different official histories, similar silhouettes, similar sidewalls, similar crowns. This is where coincidence becomes a system. The theory survives not because any one mountain looks like a stump, but because the same impossible resemblance appears over and over under different names. If there was an older reality here, it does not require a theatrical conspiracy to explain its disappearance. It requires something more ordinary and therefore more durable. Institutional inertia, professional specialization, educational compression, legal categories. Once a formation enters a map, a paper, a museum label, a land management plan, and a textbook under one definition, every later observer inherits the definition before the observation. Funding follows accepted questions. Careers form around accepted mechanisms. Data that fit the framework are refined. Data that do not fit are filed as curiosity, folklore, error, or visual coincidence. Classification itself becomes the filter. In some cases, military mapping, mining interests, and restricted surveying may have narrowed access to certain regions. In other cases, there was no need for secrecy at all. The limits of accepted categories did the work more efficiently than censorship ever could. The record is still there. It is simply distributed across the wrong shelves. There is also the matter of buried infrastructure. If mountains were once stumps, then where are the roots, the fallen trunks, the cut marks, the processing sites? Fragments may already sit in plain sight under different labels. Petrified forests with logs too large to fit ordinary ecosystems. Coal seams interpreted as compressed swamp biomass, but occurring on scales that imply biological abundance beyond modern analogues. Silicified strata with wood-like cellular patterns. Long ridges submerged in sediment as though massive linear bodies were laid down and mineralized. Circular quarry-like scars later reclassified as calderas or impact structures. None of these features proves the theory by itself, but theories change when previously separate categories begin to interlock. A stump without roots is weak evidence. A stump near root-like ridges, surrounded by debris plains, paired with oversized petrified matter and repeated across continents, becomes something else. Not proof, a pattern. And patterns matter because they change the emotional temperature of the archive. At first there is wonder, then doubt, then recognition. After that comes something colder, the possibility that an entire layer of reality can vanish not through destruction alone, but through renaming. Once the mountain becomes a neck, The question of whether it was ever anything else sounds childish. Once the plane becomes a basin fill, its resemblance to spoil loses legitimacy. Once the petrified trunk enters a museum case as a specimen, its original scale becomes abstract. Civilization does this constantly. It preserves fragments by shrinking their meaning. The stone remains, the category changes. So the mountain stands there, immovable and reinterpreted. Tourists circle it, geologists sample it, drones film it, children are taught how it formed. And perhaps the official explanation is broadly correct. Perhaps every resemblance to wood is a trick of fracture and weather. Perhaps every flat summit is caprock and time. But if even a fraction of these formations are what the hidden theory suggests, then the landscape is not merely ancient, it is aftermath. It is the remains of a biosphere so large that modern language can only reduce it to rock. That is why the idea persists. Not because it is comfortable, but because certain places still look like evidence. In the end, the most unsettling possibility is not that the world once held trees 40 miles tall. It is that the remains of something on that scale could still be visible and yet remain unthinkable, protected not by armed secrecy but by ordinary explanation. A name, a label, a chapter, heading, a model that answers enough questions to prevent better ones. The mountain does not argue, the plane does not explain itself. The photographs keep their silence, and the real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.